From the November 2019, question 10. During an experiment, light of different frequencies is radiated onto a silver cathode of a photocell, and the corresponding maximum speed of the ejected photoelectrons are measured. A graph of the energy of the incident photon versus the square of the maximum speed of the ejected photoelectrons is shown below. 10.1. Define the term photoelectric effect. So this is the process whereby electrons are ejected from a metal surface when light of suitable frequency is shown on it. Use the graph to answer the following questions. 10.2. Write down the value of the work function of silver. Use a relevant equation to justify the answer. So we have three scenarios for the photoelectric effect. The first one, when the energy of the photons is greater than the work function. Here, the photoelectric effect will happen. The second one, when the energy of the photon is equal to the work function. Here, electrons will only lift, but no movement. And the third scenario, the energy of the photons is less than the work function. So here nothing happens. So here, the y-intercept will represent your work function, because we know that in order for us to be able to determine the work function, the second scenario should hold true. So the energy should be equal to the work function plus half v squared. So from 0 to 7.48, when you look at that graph right here, from 0 to 7.48, there is no speed of the electron. So if there is no speed, it means that the energy that is supplied by the photons is less than the work function. So nothing happens. You have no speed. But at that point right there, the energy of the photon is equal to the work function. So we will say that E should be equal to WO, the mass of the electron, when the speed is 0, because there is no speed from 7.48 going downwards. But at that point there, so the energy should be equal to WO. Therefore, WO should be equal to 7.48 times 10 to the exponent of negative 19 joules. 10.3. Which physical quantity can be determined from the gradient of the graph? E should be equal to half the mass of the electron v squared plus the work function. This is y is equal to mx plus c. Notice how the work function is the y-intercept there. So this answer right here, it still holds true, because the y-intercept should be what? The work function. On the x-axis, we have v squared. And then the gradient, it means that the gradient should be represented by half the mass of the electron. Therefore, the gradient is half the mass of the electron. Calculate the value of x as shown on the graph. So when v squared max is x, the energy should be equal to 11.98. So the energy is 11.98 times 10 to the exponent of negative 19. The work function is 7.48 times 10 to the exponent of negative 19, plus half the mass of electron is 9.11 times 10 to the exponent of negative 31 V squared. So I'm getting 9.89 times 10 to the exponent of 11 meters squared multiplied by s squared, because that's what the units are there. So the experiment is now repeated by using light of a higher intensity. How will each of the following be affected? Choose from increases, decreases, or remain the same. The gradient of the graph. The gradient is given by half the mass of an electron. Since the mass of an electron is a constant, it will remain the same. Point 2. The number of photoelectrons emitted per unit of time. When you increase the intensity, it increases the number of photoelectrons that are emitted per unit of time. So this is increases.